We are commonly taught that the Earth is made of stardust, leftover star material that was expelled from a supernova. This assumption gave rise to the idea that radioactive decay of certain elements created by these stars, another big assumption, could be used to measure the age of the Earth. Earth's radioactivity is often cited as the reason why Earth has not completely solidified over billions of years and why there is much geothermal heat coming up from below. While that may seem like a satisfactory explanation for these issues, there is much contradictory evidence. In fact, the lightning we see during a storm gives some clues to the remarkable origin of radioactivity on Earth. The hydroplate theory will further show that the root cause behind this radioactivity is uniquely explained by the extraordinary conditions produced by a global flood. The theory of chemical evolution claims that the Big Bang occurred 13 to 14 billion years ago. Conditions were so severe that this initial event only produced the lightest three elements of the 94 found in nature: hydrogen, helium, and lithium. Chemical evolution theory maintains that the remaining elements were cooked in stars and ultimately produced and spread throughout the universe when the stars ran out of fuel and exploded as supernova. It is assumed that our solar system, including the Earth and all the radioactive elements found on Earth, gravitationally accreted from the debris of this explosion. Heat generated by the many impacts of this accretion supposedly resulted in a molten Earth for approximately 200 million years. After 200 million years, the accretion ceased, so the liquid Earth cooled and heat was radiated into space, forming a crust. The radioactive parent elements trapped in and on the Earth then decayed into daughter elements we find today. Today, the ratio of the number of parent to daughter atoms is measured. The decay half-life is then factored in to arrive at a radiometric date for any given rock sample on Earth. This assumption about the past is the foundational rationale for old Earth theories. Many leading evolutionists assert confidently that the Earth and everything in it came about from stars exploding. Some realize, though, that all the physics has not been worked out to back this claim up. Another problem with this idea is that much evidence collected from similar nearby rocky planets like Venus and Mars suggests that they have very cold cores and or show little radioactive decay. This is odd, assuming that all the planets formed from the same stardust. Earth's core is hot, while its crust contains much radioactivity. Conditions on Earth are very different. Here's why. The binding energy is what holds an atom's nucleus and all of its positively charged protons together. The binding energy per nucleon, that is, either a proton or neutron, changes depending on how many protons and neutrons the chemical element has. Here we see a chart of the average binding energy per nucleon for each element. The elements are shown on the x-axis by the number of nucleons they have, and the y-axis shows the average binding energy per nucleon for a given element. Light elements are on the left and heavier elements are on the right. Notice there is a peak in this data at around 60 nucleons. The binding energy per nucleon is as high as it can be, and anything heavier sees a drop in the energy holding nucleons together. The evolutionary explanation might work for nuclei with less than 60 nucleons, but this is because fusion events for light elements result in increased binding energy. For example, if two deuterium nuclei fuse into one helium-4 nucleus, you can see that the binding energy per nucleon increases, meaning the new helium nucleus is held together more securely than the two deuterium nuclei. If the data kept climbing up and to the right, all would be well for chemical evolution theory. As you can see, this is not the case for elements heavier than 60 nucleons. Trying to merge any of these heavy nuclei in the chaos of a supernova will always result in less binding energy. They will break up or fission. The larger the nucleus, the greater this tendency, as there is less and less binding energy holding it together. This is the data that causes chemical evolutionists to look to physicists and hope that they will eventually figure out why cosmological theory doesn't match observation. And this is why the United States National Research Council, in the year 2000, listed the following as one of the 11 greatest unanswered questions in physics. How were the heavy chemical elements from iron to uranium made? Textbooks and teachers rarely explain this problem. Here's why we see a peak in the data at around 60 nucleons. If you think about it, like charges repel, so an atom's nucleus should fly apart because of this Coulomb force. Any nucleus with even two positive protons should fly apart due to the Coulomb force. Of course, this does not occur because the strong nuclear force takes over at extremely short distances. Think of the strong force as a powerful magnet with very short range. If protons get close enough, the strong force will slam them together in spite of the Coulomb force. Understanding this relationship between Coulomb and strong nuclear forces is key to understanding why heavy elements become increasingly unstable and tend to fission no matter how big and powerful a supernova is. Even the tremendous kinetic energy inside a star cannot overcome this Coulomb force for heavy elements. As we can see, a nucleus with 60 or more protons and neutrons has a diameter so big that not all the protons are within one another's strong nuclear force field of attraction. So the Coulomb force tries to push these outer protons apart. Impacting particles during a supernova would only tend to aid the Coulomb force in breaking up the nucleus. Instability of large nuclei leads to decay. The larger the nucleus, the more unstable it is. This is why heavy elements like uranium are radioactive. We will discuss several types of decay. Of course, fission is when a nucleus breaks apart. The resulting fragments will reform into any number of smaller elements and isotopes. Beta decay occurs when a neutron in the nucleus becomes a proton and an electron is expelled. The electron is called a beta particle. Alpha decay occurs when a tight bundle of 2 protons and 2 neutrons are ejected from a nucleus. The alpha particle is actually a helium nucleus. Much is made of the extremely old dates that radioactive dating supposedly shows. However, alpha particles produced during this decay are rarely discussed because, as we'll see, they tend to tell a much different story about the history of the Earth and its age. Zircons are durable minerals that contain uranium. The uranium that has decayed in the zircons indicates they are 1.5 billion years old. However, the helium produced by the uranium's alpha decays gives a much different picture. Think of a zircon as a leaking helium balloon. If 1.5 billion years of time has gone by, then the balloon should be empty. However, measurements of the rate of helium loss in zircons indicates that they remain astoundingly full, with data showing that only 4,000 to 8,000 years of helium loss has occurred. If supernova did not cause nucleosynthesis of heavy elements, what did? Where is Earth's radioactivity located? Looking first at an evolutionary model and following well-established laws of heat transfer, we'd conclude that after billions of years of radioactive decay and assumed mantle crust circulation or convection, that the heat produced should be uniformly distributed throughout the Earth's crust and mantle. This idea, however, is not supported by the data. Measurements all over the world show striking differences in the distribution of heat. While radioactivity produces heat, it is not safe to assume that lots of heat means radioactivity is the source. For example, ocean floors are releasing a great deal of heat, however, little radioactivity exists there. In startling contrast, Earth's continents are releasing slightly less heat than ocean floors, yet we find 70 times more radioactivity concentrated on our continents. In addition, the radioactive heating on the continents is spotty and not uniform. Interestingly, the ratio of deuterium, or heavy hydrogen, to normal hydrogen in Earth's oceans is only half that found in comets. Deuterium is created when hydrogen atoms in water molecules are bombarded by neutrons. If the Earth's water came from comets, why do our oceans have only half the deuterium concentration as comets? What produced the deuterium, and why is there a difference in these ratios? Many believe that nuclear reactions are occurring deep inside of Earth's core, and that the heat released by these reactions is the cause of geothermal heat. Measurements taken in the world's deepest drill holes show that temperatures rise very rapidly with depth. If deep radioactivity from Earth's core is the source of this heat, then the temperature increase with depth would mean that everything below 50 miles would be melted. However, seismic data from thousands of earthquakes show conclusively that the mantle rock is solid down to about 1,800 miles. Carlslau and Jaeger reveal that while the distribution of radioactive elements in Earth is unknown, the radioactivity must be very shallow, not deep, and confined to Earth's thin granite crust. This means the radioactivity is concentrated in the primarily granitic continental materials. So the answer to this first question, Earth's radioactivity is not uniformly distributed throughout Earth, as is expected if Earth evolved. Instead, we see that radioactive elements are concentrated in Earth's granite continental crust. The hydroplate theory will explain why. We now must answer a second question in order to see how heavy elements were created. What conditions or forces could overcome the Coulomb force? Two possibilities exist. They are the Z-pinch and shock collapse. Returning to the bolt of lightning, let's discuss what it is. Atmospheric lightning is a plasma. A plasma occurs upon electrical breakdown of any substance. In this case, the air molecules, mostly nitrogen and oxygen, have been transformed from their normal gaseous state to plasma. This happens as the electrical potential, or voltage, between the clouds and the ground increases above air's dielectric strength. The result is a massive flow of electrons, a current that arcs between the clouds and the ground. After a lightning strike, showers of gamma rays and a burst of neutrons are detected, a result of nuclear reactions and radioactive elements produced by the lightning. So what is happening within the plasma? When electrical current travels through close, parallel wires, a very powerful pinching force is generated known as a Z-pinch. Lightning struck this tube, causing it to be radially compressed or pinched together. The higher the voltage and the closer the wires, the stronger the pinch. In lightning, at electrical breakdown of air, the plasma produced as electrons are stripped from air's nitrogen and oxygen molecules act like closely spaced wires carrying a tremendous flow or current of electrons. So the stripped electrons follow paths that resemble the flow of electrons in closely spaced wires, but the spacing is at a minuscule atomic scale. Remember, the closer the spacing of the wires, the stronger the pinching force. Since the atom's outer electrons are stripped away, positively charged nuclei, rather than flying apart, are powerfully pinched together. The pinch is so strong that it overcomes the Coulomb force, and the strong nuclear force snaps the nuclei together, forming heavy, unstable, radioactive nuclei with short half-lives between 10 and 100 minutes. Of course, all this occurs in an instant, producing the light that we see as a bolt, and intense heat that expands the surrounding air, producing a sonic crack of thunder. This effect is similar to the research that Germany's Dr. Fritz Bosch has demonstrated. An intense electrical field will strip electrons from the surrounding heavy nuclei. Atoms become unstable and throw themselves apart, sometimes changing their decay half-life a billion-fold. The term Z-pinch is used because those first studying this phenomena were using the familiar XYZ Cartesian coordinate system in their analysis, and the compressive pinching force was occurring about the Z-axis. Had they set up the force along a different axis, we might be talking about the X or the Y pinch. This is not science fiction or theory. Researchers at Sandia National Laboratories have built this Z-pinch machine and are taking advantage of this powerful force to produce nuclear fusion in an effort to produce a controlled nuclear fusion reactor. Nuclear power plants today are fission reactors. If successful, a fusion reactor would be able to produce great amounts of cheap, clean electrical energy. The Ukraine's Electrodynamics Proton 21 laboratory has also been revealing the tremendous power of the electrical Z-pinch. While stars can only produce the first 26 or so elements, researchers are finding that a focused Z-pinch can produce the entire periodic table of elements and far beyond. Researchers at this laboratory using the Z-pinch can squeeze together a target of pure common nuclei like gold, silver, or lead into previously unknown super-heavy elements, many twice as heavy as uranium or lead. These super-heavy elements, because they are so large, are unstable and quickly decay back into the more stable 94 natural elements. The process involves passing a beam of electrons traveling near the speed of light into a target electrode of extremely pure metal to produce a focused Z-pinch, which implodes the target's nuclei into a tiny point. Because the point is so small, temperatures in the hot dot reach a staggering 630 million degrees Fahrenheit. The imploding nuclei within the hot dot merge into unstable super-heavy nuclei. The dot then explodes, producing a flash of light, gamma rays, X-rays, and many nuclei fragments of all sizes that repack into the more stable 94 or so, quote, naturally occurring elements. and isotopes, plus some super heavy elements that last for several months before decaying. Incidentally, the stable elements that are produced and are heavier than 60 nucleons end up absorbing the excess heat. Thus, the hydroplate theory solves the problem that has perplexed others. How could the Earth have withstood the heat released by so much accelerated decay? The answer is the heat was absorbed in fusing heavy elements such as uranium. This has been demonstrated in the Proton 21 laboratory. Dr. Adabenko calls it cold packing. So far, 22 different metals have been used for electrodes. All produce similar results. After subjection to the Z-pinch, a portion of the pure material is transformed into lesser amounts of all the naturally occurring elements. Why does this happen? Why do these super heavy elements decay and fragment into the 94 naturally occurring, relatively stable elements, including heavy, slightly unstable radioactive elements that are concentrated in Earth's primarily granite continents? To understand, we need to see what drives instability. Here we see the periodic table with elements color-coded according to their instability. As has been discussed, the larger the nucleus, the greater its potential instability. But this instability is not only due to size but also to the ratio of the atom's protons to neutrons. For most light elements that are stable, this ratio of protons to neutrons is high at around 1, close to 50% protons, 50% neutrons. For very heavy elements to remain somewhat stable, this proton to neutron ratio drops to around 0.67, or roughly 40% protons to 60% neutrons. Remember this difference between these two groups of elements. Now consider what happens when a Z-pinch of many small light nuclei produces a large super-heavy nucleus. Since the large nucleus has been made up of merged lighter nuclei whose proton to neutron ratios are 50-50, the new super-heavy nucleus will retain the same 50-50 ratio, and therefore it is extremely unstable. When all the elements and their many isotopes are plotted according to their proton to neutron ratios, and then given an instability rating, the pictured chart is produced. What we see is that if you have too many protons or too many neutrons, the nucleus is extremely unstable, shown here as 100% unstable, and will immediately break up or decay. Stable elements that we are familiar with are located down in what is termed the valley of stability. Notice that the valley curves to the right, between points A and C. The 50-50 proton to neutron ratio line is shown between points A and B. Viewed from directly above, we can now see the bottom of the valley of stability. We see that uranium-238 is somewhat stable with a half-life of 4.5 billion years, and it plots on one of the side walls of the valley. Uranium-238 eventually decays into lead-206, which is stable at the very bottom of the valley. One of the decay products, while uranium-238 decays toward lead-206, is polonium-218. It is very unstable, and we see that it plots along the high rim of the neutron-heavy plateau of instability. Polonium-218 has a half-life of only 3 minutes. Here is the 50-50 ratio line again. Remember, lighter elements have proton-to-neutron ratios near the 50-50 line. If Z-pinched together, these light elements form heavier elements with the same 50-50 ratio. They lie high on the proton-heavy side of the plateau of instability, and quickly fission into many smaller fragments, some of which are still radioactive and unstable, like uranium, polonium, etc. We now can see why many question the validity of assuming that uranium-238 to lead-206 and all other parent-daughter decay ratios represent the age of a rock sample. If powerful electrical currents that were once a consequence of a global flood produced radioactive elements, then many mysteries of Earth's radioactivity are explained. Radiometric dates are meaningless. For evolutionary theory, the alleged mountain of data in support of great uniformitarian epochs of time really adds up to nothing more than a very precise set of ratios, not dates. But how does hydroplate theory tie Earth's radioactivity to a recent global flood? The key to seeing how Earth's radioactivity is concentrated in Earth's continental crust is to recognize that the main rock found is granite. Unlike basalt that covers the ocean floors, granite contains a great deal of the mineral quartz, about 27% quartz. Quartz crystals are arranged in such a way that they will produce an electrical potential, or a voltage, if they are stretched or compressed. Such materials are said to be piezoelectric, piezo meaning pressure. Ever wonder how your gas grill can light the propane by simply pushing a button that has no battery. The snap you hear at the end of the button stroke is a spring slamming into a quartz crystal, causing it to compress and give off a spark, igniting the gas. Here is a similar device that allows us to see what is happening without tearing apart your grill. A child could push or pull on the lever and produce enough pressure in the small quartz pellet to produce a 4,000-volt spark. Imagine the voltage produced on a continental scale instead of this display. Some may ask what evidence there is that granite could produce electrical charges. Here are some quotes taken from eyewitnesses around the world. Of course, today many witnesses have uploaded YouTube videos of these strange lights during large earthquakes. Many scientists have begun to link the root cause of these accounts as being due to the piezoelectric materials in granite being stressed during an earthquake. Hydroplate theory shows that during the flood, the granite continents were exposed to more extreme cyclic pressures on a much larger scale. Hydroplate theory poses that during the beginning stages of the flood, as supercritical water rocketed out from under the fractured plates, water flowing under the plates, in combination with seismic waves sent throughout the plates, due to the buckling failure of the plates' supporting pillars, induced flutter in the granite plates. So what is flutter? Whenever a fluid flows over a flexible surface, a vibration or flutter can be induced. This is easily seen in a flag flapping in the wind. Flutter is a phenomenon that must be considered in designing aircraft structures like wings to prevent their fatigue. So what evidence is there that Earth's massive granite continents once fluttered? Lineaments are very long parallel fractures that have been observed on the surface of Earth's continents. Some unique properties of lineaments are that the material on either side has not been displaced and does not change in elevation. We can postulate several failure mechanisms for these features of lineaments. However, only one is consistent with observation. Looking at compression, we see that compressive failure or crushing or impacts would not produce long, thin cracks, but many randomly directed fractures and displacements. The continent could have sheared, but shearing would produce displacements. Horizontal tension may be an option, but horizontal tension would pull a slab of rock apart at one single point of failure and not produce multiple parallel fractures. Finally, consider tension in bending. This mode will produce multiple parallel fractures in a material. Rather than displacing, they will simply close back together once the bending load is removed. Of these failure modes, lineaments seem most likely to be tension cracks formed due to bending at some point in history. Here's how lineaments formed due to flutter. The wave that flutter produces causes a structure to bend back and forth as it flexes. This flexing produced the long, undisplaced parallel fractures we see today on the surface as lineaments. Think of a simple two-dimensional beam as loaded, shown here. Notice the parallel red lines at the ends of the beam. The loads will cause the beam to deflect into an arc. The convex side is in tension as the material stretches past the red lines. The neutral axis of the beam in the middle is neither in tension or compression. The concave side is in compression, as the material is squeezed between the red lines. While granite has excellent compression strength, its tensile strength is very weak. This property of granite, combined with the bending from flutter during the flood, produced the lineaments we see today. During the flood, continental hydroplates began to flutter as an ocean of water flowed under and burst out of the crack. Piezoelectric quartz fills these granite plates, which were exposed to cyclic tension and compression that produced huge voltages throughout the granite. Just as the dielectric strength of air breaks down in an electrical storm, granite's dielectric strength was exceeded, resulting in powerful electrical surges, or plasma, arcing within the fluttering plates. Each time the supporting pillars were lifted and then slammed down into the mantle floor, tremendous compressive pressures crushed the pillars. Like the Proton 21 lab experiments, self-focused Z-pinches occurred at microscopic points within the pillars. The high temperatures, on the order of 630 million degrees Fahrenheit, at each point was enough to melt a millimeter or two of surrounding rock, creating small chondral spheres. Some of these fragments were launched into space and fall back to Earth today as meteorites. A bit later we'll discuss how these tremendous velocities were achieved. The arcing lightning, or plasma, strips nearby elements of their orbiting electrons. In this case, the elements involved in the Z-pinch were those that comprised of granite rather than air. The elements that make up granite were vaporized into a plasma state, stripped of their electrons, setting up the conditions for the Z-pinches to occur. Next, we'll see a second mechanism that could have aided in heavy nucleus building. Lightning in the deep granite led to further nuclear fusion via shock collapse events. As rock became plasma along the thin pathways of the electrical discharge, the shock wave generated by the electrical heating suddenly expanded the plasma and the surrounding rock walls. With air, this shock wave causes thunder. However, the deep granite was not able to expand like air. Instead, the surrounding rock walls were momentarily expanded by the shock wave, but then rebounded like a giant compressed spring from all directions. The rock collapsed back into the plasma with enough shock energy to drive or fuse the nuclei together at various places along the plasma paths. This happened frequently deep in the crust where the rock was already highly compressed. As can be seen, light nuclei that make up granite, like silicon, oxygen, magnesium, iron, aluminum, fluorine, calcium, potassium, and sodium, were Z-pinched into super heavy, highly unstable elements, which then fissioned rapidly and randomly produced many new elements and their isotopes, some of which were heavy and radioactive, like uranium, thorium, polonium, radon, etc. In addition to producing all kinds of new, heavy, unstable elements, another series of chain reactions would have occurred at the nuclear level within the granite plates. These reactions transferred much of the generated heat into the subterranean water. In addition, they also caused the accelerated radioactive decay of newly created heavy elements. This massive electrical plasma storm surged within the granite and produced a sea of flowing, accelerating electrons, which passed close by surrounding granite nuclei and any newly formed elements. This decelerated or accelerated the high-speed electrons, producing secondary Bremsstrahlung radiation. Bremsstrahlung is a German term for radiation produced by either decelerating or accelerating an electron. The result was the release of a photon. These high-energy photon showers were accelerated and decelerated by the surrounding nuclei, which in turn produced a sea of free neutrons. Many of the nuclei affected by these electron, photon, and neutron showers were the newly formed fission fragments of unstable radioactive heavy elements. In this unique and turbulent environment, these nuclei experienced accelerated radioactive decay rates that were orders of magnitude faster than the decay rates measured today. Missing the evidence of this catastrophic event gives many the false impression that eons of time have passed because of the ratios they measure. However, we can see that this new theory of events shows that these ratios have nothing to do with age. In the lower levels of the plates, where for centuries prior to the flood, supercritical water had eaten innumerable porous channels up into the granite, the surging sea of free neutrons released in the granite were thermalized, that is, slowed down by the subterranean supercritical water. As a result, nuclear energy was transferred from the granite into the subterranean waters that were escaping to the surface and beyond. Some have scoffed at Walt's theory of nucleosynthesis occurring in granite, citing that the heat buildup from fission of these super heavy elements would have vaporized the entire crust. From this they conclude the theory is invalid. However, they have overlooked or ignored important details of the process. So let's discuss this alleged problem of too much heat. Remember this binding energy chart we had looked at. For elements lighter than 60, fusion results in higher binding energy, which does emit heat. However, fusion of nuclei heavier than 60 causes a drop in binding energy, which means the event absorbs heat from its surroundings. This is why the Proton 21 lab reports that the process produces a cold packing of materials and that the overall process, in spite of many secondary fission events, remains nearly adiabatic, meaning little heat is transferred to the surroundings. So while we'd expect the crust to see some heating, it certainly would not have completely vaporized or melted as some mistakenly conclude. So how was excess heat removed from the crust? Anyone who deals with heat transfer knows the purpose of these strange-looking fin features seen on engines. Friction and burning fuel creates heat that can destroy an engine. By increasing the external surface area of the engine block, more heat can be transferred to the cooler air outside, preventing the destruction of the engine. Instead of fins, when extremely efficient heat transfer is required, designers will use specialty products like porous aluminum foam to rapidly transfer heat. If supercritical water had not dissolved thin channels into the lower depths of the granite, the small surface area of the crust would have resulted in rapid heat buildup within the crust. However, the porous channels function much like the fins on an engine and greatly increased the effective surface area within the lower crust. Therefore, large amounts of heat generated by the nuclear level reactions within the crust was transferred quickly into the supercritical water below. We'll now examine the effects this heat transfer had on the supercritical water and soon see the results. Let's look at the molecular level to see what happened to the supercritical water that filled the porous granite. As discussed, some fast neutrons released by bremsstrahlung radiation thermalized the porous channels full of supercritical water, thus transferring energy and producing much deuterium and oxygen-18 in the supercritical water. Energy transfer in the supercritical water causes simultaneous evaporation of the fluid's liquid droplets into vapor. Evaporated gases expand the fluid, which pretty much had nowhere to go but down, so this greatly pressurized the escaping subterranean waters below the crust all along the flow. The supercritical water, as well as any dissolved minerals and fragments of crust pillars, were accelerated by this continuing pressure. This material was then launched and continued to accelerate high above the atmosphere. Some of it achieved high enough velocity to escape Earth's gravitational sphere of influence. The constant tumbling in the turbulent flow and sudden ejection into near absolute zero temperatures of space kept newly formed chondrules in the pillar fragments spherical, and the rapid freezing trapped many volatiles inside. Today, some of these strange rocks fall back to Earth as meteorites. Astronomers are mystified by chondrules. For example, what could have instantaneously melted so many tiny points within rock drifting in supercold absolute zero outer space? More and more astronomers are concluding that lightning must have somehow been present in outer space to concentrate enough heat to melt tiny points of rock that later became parts of meteorites. Lightning is a plausible explanation for chondrules, but it is better explained as having originated in a piezoelectric storm from the quartz inside the granite crust of Earth, not outer space. The longer a flow is accelerated, the more speed it picks up. With bullets, even bullets with the same powder charge, bullet velocity can be increased by simply lengthening the barrel as long as gunpowder continues to burn all along the barrel and provide pressure. Imagine the effect of continuous expansion of the supercritical water all along the underside of the continent-sized plates, up through the 60-mile-high crack between the plates, and high above the atmosphere. Unlike a bullet which is no longer pushed by gases outside of the barrel, the pressurized flow and anything in it would be continuously accelerated for hundreds, even thousands of miles, because every unit of volume of supercritical water is expanding as its pressure is dropping, all along the flow. In addition, the drop in pressure once the fluid was out from under the plates causes supercritical water's many ions to snap back together. This immense electrical energy released in the supercritical flow caused violent expansion and acceleration. In some cases, the velocities of the flow were high enough to launch some materials beyond Earth's gravitational sphere of influence. Of course, pressurizing the waters below created the equal and opposite reaction of pushing up on the granite plates. In some places within the continental plates, it appears that this pressure was too much for the plate to structurally support. Many large inland seas appear as deep craters. Hydroplate theory ties these features again to the unique conditions seen during the Genesis flood. Some spots of the granite plates generated more nuclear energy than the surrounding area. If too much heat were generated in this local area, then the pressure from the expanding supercritical water below could lead to catastrophic rupture of the plate. Here's another view. The newly exposed chamber floor rose up until it reached hydrostatic equilibrium and became the basin of an inland sea. The floors of these inland seas usually have thick mineral layers of salt. These mineral layers are the remnants of the granite minerals dissolved by supercritical water of the Great Deep and later precipitated by a process called outsalting that occurs in supercritical water. This was occurring decades before the Genesis flood. Because of the many neutrons absorbed by the supercritical water, we now find high concentrations of the isotope oxygen-18 in these deposits that blanket the Gulf of Mexico and the Mediterranean Sea. Finally, we can now see why comets are found to contain about 2 times more deuterium than Earth's oceans. The volume of the Great Deep was about half the volume of today's oceans. a relatively small amount of water was launched and escaped Earth's gravitation. This water remains deuterium-rich in space. Some of the launched water radiated any remaining heat into space and fell back as constant rain for 40 days, according to Genesis. Most of the remaining subterranean water continued to well up from under the plates for another 110 days after the constant rains had ceased. These deuterium-rich waters mixed with the pre-flood seas, which cut the concentration of deuterium in half, and this is why we measure diluted concentrations of deuterium in our oceans today and concentrated deuterium levels in comets. This presentation is given an overview of Walt Brown's online chapter on radioactivity's origin. I'd like to thank Dr. Brown for his input and review of this presentation. The radioactivity chapter, as well as additional information about the hydroplate theory and many evidences that support the biblical account of the global flood, may be found at the Center for Scientific Creation website.